Have you ever thought about how explosives impact your daily life? Imagine a world where products could not be delivered to your home the day after you ordered them online or within a week or two.
Imagine those products costing multiple times more than they do today. Imagine those products or services that provide a huge convenience to your life were not available or affordable.
Like a car, refrigerator, cell phone, hairdryer. Or what if the electricity to run them was not available 24/7 or just too expensive to afford?
Imagine, for almost every product you touch, use, or come in contact with to be made possible, explosives were likely involved in making them available for you and your family.
Explosives play a key role in every aspect of our lives. Oil for the energy we use, metal for that car you drive, minerals for those products and medicines we consume are all made possible because of explosives and the explosives innovations that have occurred over the past 200 years.
Now imagine what your life would be like without the vast interconnecting highways and infrastructure that keep us connected, in a world with limited copper wire to connect our homes to the power grid. Our world as we know it today
has been made possible by explosives. The full life cycle of many modern conveniences is facilitated by the use of explosives. From extraction of raw materials and product development to distribution and eventual use, explosives are paramount to preserving and advancing our contemporary way of life. The average American is estimated to consume over 3 million pounds of minerals, metals, and fuels in their lifetime, including over 900 pounds of copper, 800 pounds of lead, and 23,000 pounds of iron ore. As emerging technologies continue to develop, access to raw materials becomes increasingly vital to innovation and meeting that demand. The average hybrid vehicle requires twice as much copper wiring as traditional vehicles. A single commercial wind turbine foundation may contain over 1,000 tons of steel, concrete, and other materials obtained through the use of explosives. The most modern electronic devices, including cell phones, TVs, and computers, contain over 35 minerals, all extracted using the help of explosives. Explosives also pave the way for the transport of these raw materials and resulting end-user products to facilities and markets nationwide. 1 lane mile of highway requires approximately 38,000 tons of aggregate material. The average American will use over 73,000 gallons of petroleum in their lifetime. Even passenger car tires, while called rubber, can be made of over 60% material directly related to explosives, including steel and petroleum-based components. Every year, close to 40,000 pounds of new minerals must be mined per person in the United States alone to maintain our modern way of life. Some of these include over 300 pounds of salt are used in chemicals, highway de-icing, and agriculture. Close to 200 pounds of phosphate rock used to make fertilizers to grow the food we eat. Close to 7,000 pounds of sand and gravel are used to make concrete for infrastructure projects. 28 pounds of aluminum for beverage containers, cars, airplanes, and construction. 34 pounds of soda ash used to make glass, laundry detergent, and medicines. 11 pounds of lead used in car batteries and communications equipment. And over 9,000 pounds of stone to build our roads and bridges. Petroleum is used to make over 6,000 items, including paint, clothing, electronics equipment, antifreeze, lipstick, and even the hair coloring we might use. To power our everyday life, the average American will consume upwards of 330,000 pounds of coal in their lifetime. 400 tons of aggregates go into constructing the average modern home, from the foundation to the countertops to the granules on the shingles. A large portion of the house you live in started with an explosion. While we rely heavily on these resources to maintain our quality of life, many of the materials we take for granted each day are sourced from foreign countries due to availability and regulation. The United States imports over half of our yearly required minerals, including all our rare earths. Through their safe and efficient use, explosives are critical for technological advances, modern infrastructure, and even renewable energy. Whether you're driving to work, turning on a light switch, or sending a text message, you're surrounded by products made possible by the use of explosives.
The explosives industry was founded in the U.S. when black powder was used to mine for minerals, break rock, clear fields, and to make roads. It is unknown who invented the first explosive black powder, also known as gunpowder, a mixture of saltpeter, sulfur, and charcoal. It originated in China around the 9th century and was in wide use throughout Asia and Europe by the end of the 13th century. Commonly used in fireworks and signals, as well as in mining and building operations. Black powder is the oldest form of ballistic propellant and was used with early muzzle-type firearms and in artillery. Black powder is categorized as a low explosive because it expands at subsonic speeds when it detonates. High explosives, by contrast, expand at supersonic speeds, creating much more force. In 1831, William Bickford, an English leather merchant, invented the first safety fuse. Safety fuse made black powder explosives much more practical and safer to handle. High explosives and the cleaner smokeless powder, such as what is currently used in firearms ammunition, began to replace black powder by the end of the 18th century. It is not an overstatement to say that this nation was built with the help of explosives. In the 1860s, Alfred Nobel, a Swede, invented dynamite and the blasting cap, which was required to make dynamite explode. He licensed it in the United States, and the Industrial Revolution began. Prior to that, in 1846, the chemical explosive nitroglycerin was discovered by Italian chemist Ascanio Sobrero and was the first explosive more powerful than black powder. Nitroglycerin, which is highly volatile, is a mix of nitric acid, sulfuric acid, and glycerol. Sobrero warned against its potential dangers after several serious accidents caused pure liquid nitroglycerin to be widely banned. But in 1864, Alfred Nobel adopted it as a commercial explosive by mixing it with inert ingredients to form a product he called dynamite. In 1867, Nobel patented dynamite, a high explosive mixture consisting of nitroglycerin, diatomaceous earth, which was an absorbent, and a small amount of sodium carbonate antacid as a stabilizer. The resultant mixture was considerably safer than pure nitroglycerin, as well as being much more powerful than black powder. Other materials are now used as the absorbent and stabilizing agents, but dynamite remains one of the premier explosives used in commercial mining, construction, and demolition. With the use of dynamite, mines could now recover deposits quicker and mine deeper, thus making mining more economical and profitable. The extracted tonnage of copper, coal, and iron ore increased 100-fold. New industries emerged. Some seem so basic today that it is difficult to imagine a world without explosives.
In 1884, 25 years after the discovery of oil in 1859 at Drake's Well in Titusville, Pennsylvania, a new use for nitroglycerin was developed by the Roberts Torpedo Company to fracture oil wells and increase daily production rates. 4 years later, an American chemist, Charles Monroe, discovered a method of focusing blast energy using a hollow or void cut on a surface of an explosive. Known as the Monroe effect, this focusing of blast energy was used during World War II to develop shaped charge munitions. Since then, the effect has been put to more beneficial use, resulting in modern specialty explosive products that have replaced nitroglycerin in oil and gas well production. Today, commercial-shaped charges are used most extensively in the petroleum and natural gas industries for the completion of oil and gas wells. Their detonation perforates the metal casing of the well at intervals to admit the inflow of oil and gas for removal to the surface. The Monroe effect and the resulting specialty explosives products have permitted the development of previously inaccessible natural gas and oil reservoirs. Quarrying, with the help of explosives, allowed materials such as limestone, cement, and concrete to replace bricks and cobblestones, and eventually became the common building products we know today. Harbors were deepened and widened, railways and roads pushed into the wilds, and dams were built to help create enough electricity to pave the way into the 20th century. America found dynamite to be the new muscle or power tool that drove growth to all industries, including oil and gas exploration, power production, mineral mining, as well as pipeline, tunnel, and highway construction. In the age between the close of the Civil War and the end of World War II, no single engineering tool surpassed the achievement of dynamite.
In 1863, TNT, or trinitrotoluene, was invented by German chemist Joseph Wilbrand. Originally formulated as a yellow dye, its explosive properties were not immediately evident, but it was stable enough to be safely poured into shell casings. In the early 20th century, TNT came into standard usage for German and British military munitions. Considered a high explosive, TNT is still in common use by the military for munitions and by explosive companies around the world in the manufacture of cast boosters. Over the last 50 years, this workhorse for industrial progress has been joined by even more efficient and safer explosives products known as water gels, emulsions, and many more economical, less sensitive bulk delivery systems. Ammonium nitrate, which was historically mined as a natural occurring mineral, is now virtually 100% synthetically produced. By itself, ammonium nitrate is not an explosive, but readily forms an explosive mixture with varying properties when combined with a fuel such as diesel fuel oil. ANFO is a mixture of ammonium nitrate, commonly called AN, and fuel oil, FO, and is widely used as an industrial bulk explosive today. It is used in coal mining, quarrying, metal mining, and civil construction. Since the mid-1950s, a variety of additional explosives have been developed based upon ammonium nitrate. In 1956, Dr. Melvin Cook developed the first commercial slurry, which has the advantages of being a waterproof ammonium nitrate, available in bulk or packaged forms, and can be formulated as a high explosive or a blasting agent. Multiple non-explosive chemicals are used in the manufacture of slurries. Water gels and slurries are considered similar products in the world of industrial explosives. Emulsion explosives were first developed by Atlas Powder Company in the late 1960s and are a water-in-oil formulation. Typical components include microscopic ammonium nitrate particles dissolved in water surrounded by an oil phase emulsifier mixture. Density control agents may be added, such as glass or plastic microballoons for sensitizing purposes. Some formulations also include sodium nitrate or calcium nitrate as an oxidizer. The advantage of emulsions is in the simplicity of the formulations and their availability for use in bulk or packaged forms. In addition, the various formulations can be sensitized to be a high explosive, a blasting agent, or left as an oxidizer depending on the application demands.
Initiation systems have significantly evolved throughout the past 200 years to make blasting much safer and more efficient than ever before. Prior to the invention of safety fuse in the 1830s, it was common for blasters to use a goose quill filled with black powder to ignite the main black powder charge, which too often resulted in fatalities. At the dawn of the modern era, safety fuses saved countless lives and became the standard initiation product for many years. In 1863, Alfred Nobel invented the first fuse cap. This was another giant leap in technology that allowed for the safe initiation of another recent development, nitroglycerin. Electric detonators were first developed in the 1880s, while half-second delay electrics became available in the early 1900s. By the 1940s, millisecond delay caps were introduced, opening the door for the development of modern-day blast designs. Electric detonators emerged as the standard, but were eventually overtaken by the introduction of non-electric detonators. Detonating cord, which is a flexible, small-diameter braided or spun rope with an explosive core, was invented in France in 1907 and played a prominent role in the blasting industry for many years. Various forms are still used today for specific applications, providing a number of safety advantages over early electric detonators, such as immunity to stray currents and radio frequency energy, commonly known as RF energy. The first shock tube detonator, which incorporated a hollow plastic tube with a small dusting of explosives on the inner wall, was invented in 1967 by Dr. Per Anders Persson of Nitro Nobel AB in Sweden. This eventually became commonly known as non-L, which is a registered trade name or non-electric. This became popular due to its non-disruptive nature when detonated, as well as its immunity to static, stray currents, and RF energy in the field. The reactivity of the tubing allowed an unlimited level of sequencing and blast design flexibility, which also increased its popularity. Several other non-electric systems have been developed, but shock tube products remain one of today's most commonly used initiation systems. More recent advances in explosive product technology has been the development of electronic initiation systems. Early prototypes were first developed in the 1980s and became commercially available in the late 1990s. A number of manufacturers have developed their own unique systems, but many similarities do exist between all of them. The latest drive-in product evolution is wireless electronic initiation systems, where two-way communication is achieved through RF or leadless technologies. Electronic detonators provide millisecond delay accuracy, individual detonator programming, testing of each detonator, and an ability to interrogate the entire network. This has opened the door to improved blast design techniques, as well as enhanced safety, productivity, and environmental controls. These blasting systems are harnessing the technology of today's world to blast more safely in the future. Explosives allow us to extract the minerals and rare earth materials that make products and services available to us, including technologies needed to launch rockets that place satellites in orbit for communications around the world. Today, the majority of explosives products in use are ammonium nitrate-based blasting agents that can be transported as oxidizers and sensitized only when ready to become blasting agents or high explosives for work at the job site. There are 4 basic types of explosives products needed for the safe, reliable, and efficient use of this power tool. These product families are packaged explosives, which are dynamites, emulsions, water gels or ANFO-type products that are individually packaged and designed for precise loading of energy and easy use for small diameter blast hole work. Bulk explosives are the same ammonium nitrate-based type of explosives found in packaged form, but are transported and loaded by trucks and equipment for blasting applications that can utilize larger blast holes to provide the most efficient, cost-effective energy distribution and work for large mining, quarrying, and construction jobs. The third family comprises the initiation system products, or the brains and control of the energy being released in a blast. They are also the products that provide the precise transfer of initiation signals to the actual power tool, the blast hole's explosives. There are also numerous types of specialty explosive products we have come to rely on, but seldom ever see or appreciate the work they do in our daily lives. These products can be found in oil and gas production, in safety devices for our automobiles, as components of fire extinguishing systems, and in rescue and escape applications used by those who protect us. As we've discussed briefly, Packaged explosives are explosives products that are individually wrapped or cartridges of explosives. Generally, the cartridges are produced and boxed for shipment to job sites and are used in a broad range of applications. Packaged explosives in use today can be found on job sites in the form of dynamites, emulsions, water gels, and bagged ANFO products. Dynamite, even though it was one of the first innovations in the industry, is still in use today and found in applications where reliability is critical and tough blasting conditions exist. Whether it's in extreme cold conditions, hunting for oil in the Canadian Arctic, or excavating large trenches and hard rock for pipelines, dynamites are packaged forms of nitroglycerin-based products that also contain other energetic materials like ammonium nitrate. Dynamites are produced in wrapped paper, cardboard, or plastic cartridges for easy use and deployment down blast holes. Packaged emulsions and water gels, commonly called slurries, are formulations that include microscopic ammonium nitrate particles dissolved in water and surrounded by an oil phase emulsifier mixture. In the case of water gels, a cross-linking agent is used to form a more rubbery and highly water-resistant property to provide resistance to water desensitization and contamination. Generally, product formulations use density control agents such as glass or plastic microballoons to provide the needed sensitivity for reliable initiation. These products are produced in two basic formulations depending on the sensitivity needed for the application. A high explosive or detonator-sensitive emulsion, which is a 1.1D classification material, can be produced for those small-diameter blast hole applications needing high energy and only a detonator to initiate the cartridge. A blasting agent or 1.5D classification product is designed for blasting applications where a less sensitive product is needed and/or a more economical power tool approach is required. Unlike 1.1D class products, blasting agents require a booster charge to initiate the cartridge due to their lower sensitivity to initiation. Both emulsion and water gel packaged products are used in broad applications, but are particularly useful where wet conditions exist, and close tolerances are needed in loading of blast holes.
A broadly used product by today's blaster, especially for smaller diameter construction type projects, is a hybrid of packaged and bulk forms of ammonium nitrate-based products. Bagged ANFO, which is a mixture of ammonium nitrate and fuel oil produced in 50-pound or 25-kilogram bags, provides the power tool engineer with a simple borehole loading technique with no need for extra mobile equipment or trucks to load the AN product. Multiple types and variations of mixtures are available for this power tool and workhorse in the industry, providing the blaster options for increased water resistance, densities, and/or energy. Bulk explosive products are generally available in the same three ammonium nitrate-based type of packaged products mentioned earlier: emulsions, water gels, and ANFO. These products are produced in large batches or a continuous manufacturing line and loaded into bins or trucks for storage. They are then transported to job sites in tankers or bulk trucks for deployment down larger blast holes than where commonly used packaged products would be found. The bulk form of use allows for very efficient loading and economic placement of these materials in the mining, quarrying, and construction industries. Bulk ANFO is a significant percent of the bulk explosive products in use today. Bulk ANFO, a blend of ammonium nitrate and fuel oil, is loaded down blast holes with specially designed trucks to provide increased efficiency and precise control of the ANFO blend. Bulk ANFO can only be used where dry blast holes are found to ensure proper detonation of the blasting agent, since water or moisture can degrade its energy properties and effective work. Emulsion and/or water gel products are generally used for larger scale applications where more energy and effective work is needed due to harder rock types and tough blasting conditions. These products provide resistance to moisture and/or water-saturated ground and have similar properties to their packaged forms, but in a bulk format. Bulk emulsion or water gels can be the solution to those jobs or applications where large blast holes require water resistance and higher energy products to do the work. Both can be produced in a wide range of densities and energy levels and transported to job sites as a blasting agent or 1.5D classification as discussed earlier, or as an oxidizer or emulsion water gel matrix as a 5.1 classification, which are non-explosive oxidizers. The ease of use and ability to custom load blast holes with a wider range of product densities, either with solid additives such as plastic or glass microspheres to provide the right density, or by chemical means to provide gas bubbles. Bulk emulsion or slurries have become the preferred power tool for those larger-scale, tough blasting applications that require the most efficient form of energy for mineral and metal extraction and material excavation projects today. The ability to site sensitize these products and transport a 5.1 classification material across our roads and highways allows the explosives industry to safely transport products such as oxidizers at a higher level of security. Initiation products in use today have evolved into several key types, with electronic detonators, sometimes called smart detonators, as the latest evolution. Safety fuse, detonating cords, electric, non-electric, as well as electronic initiation products are all in use today. Electronics, which use a microprocessor technology to provide the precise timing controls, have become a leading technology in increasing the efficient work of explosives for all types of blasting. Electronic detonators provide today's user with a high level of safety and security advantages by being immune to issues of stray currents, static, and extraneous electrical energy. Electronics also provide users and the industry with the ability to prevent unauthorized use with the integration of passcodes and software interfaces to energize the systems and fire a blast. The fact that today's electronic detonators can be tested using two-way communication, programmed to any delay time, and reprogrammed multiple times based on changing circumstances just prior to the firing, makes software a unique and powerful tool for today's blaster. There are several other detonator technologies in use today that provide high levels of safety and reliability. Non-electric detonators, shock tube products as we know them, detonating cords, electric detonators, and cast boosters make up a vast array of initiation products that are used to control and manage the explosive products available to the blasting and explosives engineering professionals in the field. Often going unnoticed or detected by the public, explosives sometimes provide critical, life-saving functions. There are also thousands of specialty devices and other explosives products that provide value to each of us on a daily basis. Today's explosives products and technologies have evolved over decades to become an unmatched level of energy efficiency, making the world safer for all of us and the products we use that much more affordable. Imagine a world without the technologies that we all now take for granted. Our parents may not even have imagined many of the things that now make our lives easier, safer, and more productive. But at some point, someone saw the need for every new technology and imagined how it could improve our lives. Someone had to design it, build it, and bring it to the consumer. The same is true for the blasting industry, and we all benefit from such innovation in one way or another. Today's blasters and explosives engineers have so many more tools previous generations could not conceive of. Blasting applications today are much more demanding in terms of safety, control, and outcome than in the past, which in turn requires better training and a more disciplined approach. Blast engineers can now utilize blast design software to model the blast from a three-dimensional perspective, allowing a virtual preview of the blast that predicts the outcome prior to the actual firing. This can be used to improve fragmentation, control blast vibration, and increase productivity while avoiding much of the trial and error process that historically was needed. These new software programs can be used in conjunction with the programming of digital detonators, photogrammetry, 3D laser face profiling, borehole tracking, seismic monitoring systems, and data collectors. Photogrammetry is an emerging technology that is changing the way many blasters work, allowing the blast engineer to photograph the rock face and to develop a 3D model in extraordinary detail and accuracy. This provides the blaster the information that is needed to place the right quantity of explosives in the correct borehole location to prevent unwanted noise, fly rock, and energy loss. This can also be accomplished with 3D laser profiling systems, which are typically set up in front of the blast face. User-defined points of measure are recorded, and an accurate profile is printed and given to the blaster so that each hole can be custom loaded according to its actual burdens. Borehole deviation measuring systems are becoming commonplace, and in many cases are now required. Often referred to as bore tracking, this technology measures actual borehole deviation from the drill plan design. This data can be used in conjunction with photogrammetry or laser profile data and imported into the blasting software, allowing the blaster to design and execute a much safer blast. Electronic detonators and their unique initiation systems are becoming more common as the technologies continue to advance and evolve along with industry needs. As blasting requirements become more stringent, the demand for greater accuracy, flexibility, and safety must also continue to evolve. These systems can be programmed in millisecond delay increments within an accuracy of 0.1%. Electronic systems allow for two-way communication between each detonator, the testing, and firing equipment. This allows the blaster to verify that each detonator is connected to the blast network, functioning, communicating properly, and programmed with the correct firing time prior to initiation. This helps to reduce misfires and produces a safer, more efficient blast.
One of the effects of blasting that inevitably affects people close to the operation is ground vibration and air blast. Blasters have sophisticated seismographs that accurately measure and store this data so that a blaster can see the results in real time and adjust the blast design accordingly to minimize and control vibration and noise. Most states and municipalities today require vibration monitoring and reporting. And throughout the years, acceptable limits have become more stringent at levels far below what would normally cause damage to neighboring structures and utilities. The start of any good blast design begins with accurate drilling programs. Today's drilling equipment is becoming more advanced, with smart drill technologies which are now able to monitor rock hardness, identify voids, cracks, and mud seams in the ground, along with other discontinuities within the rock in real time. These new smart drills provide explosives engineers greater information to make better decisions on explosives placement and blast design, in addition to greater drilling efficiency and a safer blast. Many drills today can also be equipped with GPS technology, allowing for blast design coordinates to be sent directly to the drill for higher accuracy in hole placement and drilling efficiencies. GPS technology can also be used to provide blast hole locations for bulk explosives loading trucks and satellite tracking of delivery trucks and equipment during the transportation of explosive materials on our highways. Inventory management and control system records are required by regulatory agencies and are also becoming more accurate as the need for explosive security increases throughout the world. Software programs and technologies are available to track and trace explosive materials from the point of manufacture through shipment, receipt, and distribution. If explosives are lost or stolen, they must be accounted for quickly. Although these types of incidents are extremely rare, it is essential for the world we live in. The IME SAFER Quantitative Risk Assessment Program is an invaluable tool to help safely position explosive storage and manufacturing facilities. This highly sophisticated modeling program, based on many years of empirical data, is in use and recognized by industry experts and regulators for keeping the public safe in the event of any unintended incidents. Our parents may not ever have imagined the level of technology available to us today. We might not have imagined either. But the technology used to ensure explosives for safe and efficient work in the form of our power tools provides each of us with products and services we have come to rely on. It is truly impressive. Imagine a career in the explosives industry with an organization that has a strong global presence. Why not develop your potential with a challenging, dynamic job? Have you thought about being part of an industry that really cares about the environment while supplying the minerals needed to support humanity? The explosives industry provides individuals with career opportunities and professional development. The industry looks for those who share a commitment to excellence and exhibit high standards of personal and business integrity. Core competencies include commitment to the team, dependability, problem-solving skills, resourcefulness, traits of leadership, and the ability to set and meet challenging goals. Not very different from other industries, just more exciting.
I decided that I wanted to pursue a degree in engineering before I decided that I wanted to be a mining engineer. When I went to the South Dakota School of Mines to visit, I checked out all the different engineering opportunities that I could find there, and mining stuck out to me because it's really where everything starts, and there can be no mechanical engineers or electrical engineers without the products that we make.
I spent 12 years in the explosives industry, working all over the country and world, and then I went back to school when I was 34 and just recently graduated in May of 2018 with my degree in mining engineering and decided to go back into the explosives industry.
If you're a person that likes to venture out and say, I'd like to spend 5 or 6 years in Australia or something like that, you could probably find a job there and everything in this industry. So I enjoy that. I enjoy getting to meet different people, different cultures, traveling, those type of things.
Besides explosives engineering, civil, electrical, environmental, chemical, mechanical, and mining are other engineering jobs needed in the industry. How about finance, accounting, and auditing? Have you ever thought about geology? Hazardous materials transportation and human resources are great jobs as well. Throughout the industry, there are many pathways to education and career development. Requirements for explosive engineers vary by field and employer.
I think there's a lot of entry-level opportunities here. This would be a good place to get acquainted with the industry, get a lot of background, get some hands-on with the product and work with the employees and make it every day, and then move forward in the organization and take that out there in different applications.
Well, this industry is very unique. Companies afford a person like me that started out as a truck driver to move on up if you're willing to learn and take responsibility. It's unlimited where you can go in this industry.
They've seen people become engineers here within 2 years of no degree or anything, so if you're willing to put in the time and effort, you can become successful in this company.
Explosives engineers, also called blasting technicians, are responsible for the safe, secure, and controlled application of explosives in mining, quarrying, construction, demolition, geophysical exploration, and many other peaceful uses. Blasting technicians apply scientific and mathematical principles to safely loosen, remove, or displace earth, rock, or other materials. This may be to access minerals, fuels, or metals in the ground, or create highways, as well as to facilitate commercial development. Many blasting technicians are employed in the metal, non-metal mining industry and construction infrastructure development industries. Blasting certifications or license requirements vary by state. Applicants often need up to 2 years of on-the-job training and hands-on experience before they are eligible to apply to take a blasting certification exam. The Bureau of Alcohol, Tobacco, Firearms and Explosives, or commonly known as the ATF, requires the blasting professional and all personnel that handle explosives to successfully complete a background check in an effort to maintain a safe and secure industry for all of us. States, counties, and cities may have their own regulations for explosives engineers. Maintaining certification may involve completing a certain number of continuing education training hours and training seminars within each renewal period. Aspiring explosives engineers who seek to advance their careers may consider joining a professional organization such as the International Society of Explosives Engineers, or ISEE, which offers a certificate program with the intent of establishing a training standard for the industry. ISEE also provides its members with continuing education programs, conferences, networking opportunities, and other resources for career growth and advancement. Whether it's a mining or quarry, construction company, an oil and gas seismic exploration or well completion company, or a drilling and blasting company excavating roads, highways, or pipelines, the career opportunities are vast. To learn more about the range of career opportunities near you, contact the Institute of Makers of Explosives or the International Society of Explosives Engineers at the website below.
It is well known that when it comes to the safety and security of explosive materials, the best practices of the commercial explosives industry exceed minimum regulatory requirements prescribed by government. The efforts of the industry, which are reflected in IME's SLP 27, Security in Manufacturing, Transportation, Storage, and Use of Commercial Explosives, and the ISEE's Blasters Handbook, have resulted in exemplary incident rates which are lower than many other trades. 20 years of available U.S. Bomb Data Center statistics have shown that commercial explosives have been involved in less than 2% of bombing incidents in the United States. Although no deaths or involvements in bombings are ever acceptable, when considered in the context that we consume 5 billion pounds of explosives in the United States every year, these very low incident rates speak to the serious safety and security commitment and advancements of the explosives industry. Safety and the reliability of explosive materials have improved significantly over the decades. Tremendous effort, dedication, and funding for research and development continue to result in improvements for the industry. Digital integrated electronic initiation systems have built-in inherent safety features coupled with the ability of diagnosis of functionality to provide the blaster with the confidence that all explosive charges are being controlled through communication. This also restricts the ability to fire the explosives only to those that are in possession of the encrypted electronic control systems. Ammonium nitrate-based blasting agents, which are generally insensitive explosives, have become the safer alternative to high explosives. Chemical sensitivity of energetic products is specifically designed to function when only intended to. Strict Department of Transportation product testing requirements ensure that all transported explosives are safe for movement through the general population. Explosive products throughout the industry are in compliance with Global Harmonization Standards, or GHS, which ensures that hazard communication via labels and safety data sheets are easy to understand and consistent with worldwide hazard descriptions, management, avoidance, and response. Industry members conduct vulnerability assessments, develop security plans which include cybersecurity measures, and are prepared to implement emergency security plans for any elevated threats. IME and ISEE maintain an open channel with agencies such as the Bureau of Alcohol, Tobacco, Firearms and Explosives, also known as the ATF, and the Department of Homeland Security to share ideas and concepts to maintain the highest safety and security standards throughout the industry. Background checks, which are mandated by many federal and state agencies, as well as by company policies, ensure that only legitimate individuals are allowed access to and possession of explosives. Strict inventory, acquisition, and disposition records ensure that explosives are accounted for from cradle to grave. Frequent explosive counts and double counts, as well as inspection of storage magazines, aid in ensuring product accountability and serve to detect any unauthorized or attempted diversion of explosive materials. Date plant shift codes are assigned to all explosive products for tracking back to the most recent legal owner, as well as the date and location of manufacture. Manufacturers are increasingly applying unique barcodes and identifiers to individual explosive articles that assist with international standards, such as track and trace in the European Union. IME has promoted harmonization of global marking standards before the United Nations. These codes aid law enforcement in locating legitimate owners of recovered explosives and assist in criminal investigations involving explosives diverted for illicit purposes. Storage requirements mandated by ATF, which include strict magazine construction and locking standards, have a proven history of securing explosive products while not in use by preventing access by unauthorized persons. Thefts of commercial explosives have dramatically decreased over the past 2 decades to single digits in some years. Explosive storage facilities must be located in accordance with quantity distance standards established by the American Table of Distances. Found in ATF regulations, these standards are presented in the form of tables of separation distances that were originally developed by IME and are published in its Safety Library Publication 2 to protect the public from any off-site consequences of unintended detonation. Additionally, quantitative risk assessment may be applied using the IME Safer software tool to ensure that explosives storage facilities and other operations such as manufacturing, storage of ammonium nitrate, loading and unloading of explosives at ports are suitably sited to protect the public from unacceptable risk. During the transportation of explosives, GPS tracking technology is becoming more widely used to track the explosives from point of origin to destination, thus ensuring that deliveries are completed safely and securely. And at the blast site or well site for oil and gas operations, standard operating procedures are developed for each type of blast to ensure that explosives are strategically placed to get the best benefit of the energy without being a hazard to the surrounding area. In addition to maintaining separation between people and the explosives, blast area control procedures also include perimeter security. Extensive training programs are in place for those individuals involved in the blasting process, such as the ISEE Blasters Training Course, member company training programs, and courses mandated by federal and state regulators. Most states require blaster licensing or certifications. Explosives industry members recognize that safety and security are necessary, integral parts of doing business. It is simply part of the business culture. The explosives industry is proud of its record of safety and security, and in partnership with federal and state agencies, will continue to develop ways to improve safety and security practices to protect employees, property, and the public.
The explosives industry is led by safety and environmentally conscious professionals whose goal is to improve the technologies as well as blasting techniques to make the world a better place to live. Safety and environmentalism is simply good for the explosives industry's business. The explosives industry has come a long way in terms of the history and development of blasting technologies and practices. Blasts that historically once filled the sky with dust and rock are now tightly controlled and monitored. The protection of the environment and safety of all individuals and property are primary concerns of the explosives industry, with diligent environmental and safety programs being implemented across the community of explosives manufacturers, transporters, and users. There are industry best practices as well as company-specific practices that support the safe and environmentally responsible use of explosives. These programs are overlaid by a variety of federal, state, and local regulations that the industry must comply with. Even in some of the most pristine environments, the explosive industry works alongside the mining, construction, quarrying, and oil and gas industries to ensure compliance to strict environmental regulations and the protection of our planet. The explosives industry produces a wide variety of explosives that are formulated for various blasting applications. Some are designed to function completely underwater or wet conditions, and thus formulated to be completely waterproof. Others have no water resistance and are used when there is no water present. The product choice is determined by the conditions, wet or dry, that present themselves in the field. The environmental effects of explosives used for blasting are generally confined to the actual blast site. These effects are known as fly rock, ground vibration, air blast, and transient dust or fumes. They are required to be monitored and held to specific regulatory levels to prevent adverse impacts outside of the permit or boundary area of the quarry, mine, or construction site, minimizing any risk of public exposure or influence. The modern blaster has access to a large variety of technical tools and products to ensure a safe and correct blast design to minimize adverse environmental effects. The potential to impact surface or groundwater with the substances used in commercial explosives can be controlled through drill monitoring, proper product selection, the implementation of process control measures, and best practices. Educating and training explosives users is a critical component in our efforts to safeguard the environment. All personnel working with commercial explosives, including blasting engineers and business owners, are continually trained to know applicable environmental regulations and to understand any potential consequences associated with the product's exposure to water. The industry also continues to focus on research and product technology development to increase the product's reliability and performance in these environments.
Selecting the proper explosives for a particular job is an important aspect to preventing water environmental impacts. Various types of commercial explosives are available to withstand exposure to water. Water-resistant explosives include the cartridge forms of gelatinous nitroglycerin, water gels, slurries, and emulsions, and bulk forms of water gels, slurries, and emulsions. Attention to all technical details of the blasting process is a primary responsibility of today's blaster and the professional explosives engineer. Not only are they responsible for loading explosives into blast holes, they are also in continuous communication with the drillers of those holes and/or are supplied with adequate drill logs. This ensures that information regarding subsurface fractures, crevices, or cavities is obtained. Where bulk ANFO or emulsion is used in fractured, creviced, or cavitied blast holes, plastic blast hole sleeves, properly positioned inert stemming decks, or other methods are used to ensure efficient detonation of the explosives and the avoidance of excessive charging. Proper drill pattern design is prepared, and drilling to plan designs are completed so that explosives are used optimally and efficiently. Quality control measures are used to maintain drilling accuracy and ensure that drilling is in strict accordance with the drill pattern design. For each blast hole, delay timing, inter-row timing, and row-to-row timing are carefully planned and selected to ensure adequate time for rock movement and minimization of the potential for cutoff blast holes. In addition to being one of the most heavily regulated industries in the world, the explosives industry appreciates and recognizes the value of protecting its employees, the public, and the environment from the start. From a history where dust, noise, and rock may have filled the sky, today's professional blasters, explosives manufacturers, and other industry professionals work together with local, state, and federal regulators to ensure the highest level of environmental stewardship possible. Whether you realize it or not, explosives are a critical part of our daily lives. Whether you're driving to work, turning on a light switch, or sending a text message, life as we know it today was in a large part made possible by explosives, the power tool.